There are many benefits to event-driven architecture. You probably already have an infrastructure set up that is mostly request and response based. You probably have a lot of the state and flow of information that's stored within databases like Postgres and MySQL. Also, you might already have some aspects of event-driven architecture in your existing ecosystem. That's because event-driven architecture is compatible with pre-existing infrastructures. That makes it really straightforward to start integrating small parts of your infrastructure as event-driven because of how seamless it aligns, and it is fully decoupled. So it's actually that decoupling aspect where you have consumers and producers. They don't know about each other, but they know that there is data available on either side, that you can easily introduce event-driven architecture even for your existing infrastructures. The kinds of technologies that you would use for event-driven architecture start at the broker layer, where you would have a Kafka or a PubNub or a RabbitMQ or some other streaming-based system that is able to have a producer and a consumer without having to worry about the intermediate that can store and forward the data, providing a decoupled experience. So that means that your producer can be online and it can also go offline, while your consumer can do the same. So you can publish and subscribe data on either side, and both systems will continue to work. As we were talking about the advantages and benefits of event-driven architecture, we kind of want to first, of course, what is EDA? What is event-driven architecture? It's a system that is specifically a software design pattern that's intended to be decoupled between various services. This allows you to scale independently each of the various services that do various workloads, which is really nice. There's a lot of benefits that go along with it, and typically you'll see the need for an event broker that will allow that decoupling to occur, because you'll have event emitters, which are your publishers. These are the producing systems. And you'll have a subscriber that is a consumer that can consume events on the other side. So of course, EDA is a flexible and scalable design pattern that allows real-time processing and fast response. There are some really good advantages that we're going to cover here really quick to see. Let's start with one of the first advantages. All right, the big one here is innovation, right? And the innovation comes a lot with that event-driven real-time responsiveness. So often you'll have devices that are they're like these things. They're like mobile apps that have apps installed in their user interfaces, and they definitely need to consume data. And what's missing typically is those apps are always out of date. They don't have the most recent information. They can go and fetch from a database some information, but then they're immediately out of date. So if you have an event-driven architecture with real-time responses, you're able to have your app connect to those streams of event changes and receive all the data immediately, so it's constantly synchronized. This kind of user experience is kind of expected today in the industry, because when you're doing order delivery, you've placed an order, you see the ETA update, you might see a position of your order on a map, and you might be able to chat and have communication with the driver or the support agent to help you understand when the food is coming, because it's lunchtime and it's time to eat. And that kind of ultra low latency allows for a seamless, immediate communication, and it is a much more engaging user experience. We're kind of expecting it today. It is 2024. We expect these kinds of experiences built into our applications. With event-driven architecture, we're looking at the benefits, and another benefit is a really good one. It's actually kind of critical. As we are humans and there's more than 8 billion of us on the planet, we need to continue to scale. The number of devices, number of servers, number of compute systems continuously is growing, and we need to have scalability and flexibility around that. With event-driven architecture is the ability to have full horizontal scaling and a distributed compute workload across all the different compute zones on the planet. There are data centers everywhere, cloud vendors like AWS, Google, Microsoft Azure. They have data centers that are spread across the planet, and you're able to connect your end users to the nearest region, and that event-driven architecture will provide really good end user experiences. And that allows your systems to scale seamlessly and based on the demand of the application by region even. And so not only do you get a good performance, event-driven architecture can help ensure that the systems seamlessly handle increased traffic and even the fluctuating demands of traffic, because sometimes there's a spike and you need that extra performance and reliability. Event-driven architecture systems and broker systems like PubNub can help you achieve this. Another phenomenal, I would say probably my favorite, benefit for event-driven architecture is loosely coupled and modularity. This provides the ability for you to continuously add more value and features that can consume the stream of data, of events, the consumers. There can be any number of consumers. They can be mobile apps, they can be servers, they can be systems that need to log the data for later tracking of events or debugging. You can have systems that process the data in aggregation to provide real-time insights and analytics. And what's even cool is you can change any of those components. You can introduce those components at any time. It's decoupled and it doesn't affect the other components. This allows you to continuously iterate quickly as an organization, and as a business you can add more features more quickly, and the overall experience is real time. We expect it to be real time. All the compute and capabilities are there, so now we have the ability to provide immediate end user experiences without any delays, without any outdated data being provided to the user. And as your team grows, your development time and operations costs, you want to make sure that all those things are as optimal as possible. With event-driven architecture, you can have multiple teams and they all interact through event-driven architecture, subscribing and publishing data to channels that allows teams to work together on the same data, different data, sharing data. It all becomes a more seamless way to scale a business and scale an engineering organization. All right, there are some challenges with event-driven architecture. Say you wanted to build your own from scratch, or even import some open source software and host it yourself in a manual way, like a Kafka system, or there's lots of open source options out there. I think Pulsar is another option, Apache Pulsar, Apache Kafka. It really all comes down to making sure that you've distributed that workload across enough servers, across enough localities around the world so that it can meet the demand of your end users, and the consumers and the producers need to match in terms of compute capability. There's a lot of sharding concepts, the different topics and replicas have to have specific scaling factors. These are some of the common challenges that you do need to pay attention to when you are doing it yourself. A DIY, building it yourself solution requires these things to be considered. That specifically goes under this scalability section here. And this there's also load balancing, right? I completely forgot about that. There's a lot that goes into it. This might have you turn to a vendor that is already hosting a real-time system, like PubNub, for example. You also have hosting vendor providers that can do behind-the-scenes event-driven architecture that works good server to server, like a Kafka situation. Now, Kafka isn't going to work well for end user experiences, where a PubNub will, for example. That's where PubNub shines, is for those end user in-app real-time experiences for event-driven architecture. It's this specifically from a scalability and overall maintainability, upgrades, security, all that thing. It's just a lot to deal with, right? So this might have you turn towards a vendor. And another, of course, is service discovery and the communication as systems scale up and scale down. You will need a broker system that is able to handle this and also communicate its broker information and its addresses to end target devices. And typically this will be, servers, could also be mobile phones and apps and web browsers.